Well, I hope you guys did okay with the circles. We're going to go on to ellipses now. And let's go ahead and start. You should be able to write an ellipse in a standard form and understand the pieces of an ellipse form, and there's just a few of them. You should be able to graph an ellipse in standard form as well, just like we did with circles. Finally, you should be able to convert an ellipse that's in general form into standard form. And that's that last step that requires that completing the square that we did with circles. That will be in part 2. This section will be broken up into 2 parts. We'll go ahead and start. What do we already remember about ellipses? Please take a minute to pause the video and write down anything you might remember or know about them. One thing you may have written down was that ellipses are ovals, which is true. And you can have an oval standing up or on its side, and please forgive my horrible drawings on those ellipses. So I'm going to play this video for you. I just want you to be aware of how you would actually draw an ellipse. Now the idea is that you have 2 points here. And if you take a piece of string or a rubber band and you make it taut around the 2 points and have a marker extend up, so again, the part between the 2 points is taut, then you can go ahead and drag this marker around, again, keeping this line straight as possible, and be able to make a very nice ellipse. So I hope you like that. Here's all the things that you need to know. An ellipse is going to have a center HK. I wrote down the horizontal major axis here. It's on your paper as well. And a ellipse that's standing up. That's the equation here. The H and the K, the H goes with the X, the K goes with the Y, no matter how the ellipse is standing, either on its side or standing straight up. A is the distance from center to major vertices, and 2A is the length of the major axis. A here in our equation is always going to be squared. So if we want to find the distance from the center to one of the vertices, we are going to have to square root it. This is the same thing for B. And finally, the most important part, C is going to be the distance from the center to the foci. In that video, the 2 little pins that we had down, that we attached the rubber band, that the person attached the rubber band to, those were called the foci. And those are going to be the 2 center points that are on either side of the actual center that allow us to draw that ellipse. So the foci are going to be pretty important when we're actually drawing. I do have some tips for you. Find H and K, and then find values of A and B. Use the center to plot the endpoints of the ellipse by using the A and B values. And I'm going to make sense of what that actually means in our first example. I'm going to rewrite this equation first of all. And I'm going to look for all of this information, what the center is, what the values of A, B, and C are, major vertices, minor vertices, and foci. The center here is going to be discovered by just changing the way that this equation is written. And that's going to be y minus 0 quantity squared. It's still going to be over 9, and we'll still have over 64, and we'll still have equal to 1. The reason I wrote this equation differently is so I could see what my k value was. I can now see that h is 2. I can now see that k is 0. So my center is 2, 0. And I can plot that on the graph here. Now A, B, and C. A is going to be whatever the square root of 64 is, which is 8. B is going to be the square root of 9, which is 3. And C, it says C is equal to if I do a squared minus b squared, or if I do c is equal to plus or minus the square root of a squared minus b squared, then I get c squared is equal to, again, a squared was 64, so I'll do 64 minus b squared is 9. 64 minus 9 is going to be 55, which means c is going to be the square root of 55, plus and minus. Now here's the real question. Is the ellipse standing up or is it on its side? And the way you know, let's get rid of this. If a squared is bigger then the ellipse is going to be on its side. So I know it's hard to read here, but if a squared is bigger, then the ellipse is going to be lying along its horizontal axis. I plotted the center 2, 0. Now I'm going to plot my major and minor vertices. And the way I'm going to do that, I'm going to take this 8, and since I know it's lying on its side, I'm going to go 8 over to the right and to the left, because again, the 8 is with the x direction. So I'm going to go 8 over from 2, 0, and that's going to be 10, 0. I'm going to go 8 in the negative direction from 2, from the center, and that's going to put me at negative 6, 0. The y value. The y value goes with the b value, and the b value is 3. So that means I'm going to go up 3 from the center. I'm going to go down 3 from the center. And once I have those points, I'm ready to connect the graph. And again, I'm not doing anything with the center here when I'm graphing. I'm just connecting those major and minor vertices. The major vertices, this time since our ellipse is lying along the x-axis, we're going to go ahead and do major vertices at 10, 0 and negative 6, 0. And I'm sorry it's a little crammed here. The minor vertices are going to be these purple values here, and those purple values were 2, 3, and it's also going to be 2, negative 3. The foci. Well, the foci is going to be plus and minus root 55. And that's going to be the distance from the center. So if I go 2 plus the square root of 55, and please keep in mind the square root of 5 is about 7-ish, maybe 7.5-ish. So if I go 7.5 to the right, then I'm going to have my right foci value, which is going to be about 9.5. And again, this is going to be a really bad drawing, so I'll just label it here. This foci value should be 2 plus the square root of 55, comma 0. And again, that value is approximately 9.5, comma 0. And then the other foci value, if I subtract 7.5, 2 minus 7.5, that's going to be about negative 5.5. So I'll label that in blue. And this foci is going to be over here. And again, since it's a bad drawing, I will label this. This is 2 minus the square root of 55, comma 0, or approximately negative 5.5, comma 0. Those are my two foci values. And now that I'm all done here, I'm going to leave you to the next example. So pause the video, try it on your own, resume when you're ready to go. Okay, this one I'm going to walk you through. Notice we have an h and a k ready to go. My h value is the opposite side of positive 3. That's going to be a negative 3. The k value will be the opposite sign of -5. That's going to be a 5. So my center is -3, 5. Give yourself a little pat on the back if you were able to get that part correct. My a and b values. Notice this value here is actually bigger. So I'm going to call this value my a. A is always going to be the bigger value. And I'll just make a little note. A is always bigger value. In the denominator. So here my a squared value is 25, which means my a value is 5. My b value is going to be 2 by taking the square root of 4. Now my c value, again, it's going to be a squared minus b squared, which is why a actually has to be the bigger number. Because if you don't do that, you're going to get a negative number. I'm going to do 25 minus 4 because that's a squared minus b squared, so I'll do this in green. I got 25 minus 4, that's 21. This is equal to c squared, which means c is going to be equal to the square root of 21 plus and minus, or approximately, if you're rounding, about 4.5, 4.6. So again, a is 5, b is 2, and the c value is going to be about 4.6. We'll call it the square root of 21 plus and minus. So now let's go ahead and graph what we have. I'll plot the a values first. I have to go up 5 and down 5. And the reason I'm going up and down 5 is because the 5, or the 25, belongs to the y value. So from my coordinate, -3, 5, I'm going to go up 5. That gets me at -3, 10. I'm going to go down 5. That's going to get me at -3, 0. For the b value, I have to go 2 to the left and 2 to the right. And the reason I'm doing that is because the 4 belongs to the x variable. So I'm going to go 2 to the right from -3, which gets me at -1, and 2 to the left from the center. Once I have those points, I can go in and connect them in a glorious fashion, in a beautiful fashion. Oh, that's an absolutely splendid ellipse. And now I'm going to go ahead and do my foci, and the foci are going to be the center. Now notice, since I have a vertical ellipse, the foci are going to be along the vertical axis. And the vertical axis is this line here, the line going up and down. So instead of doing -3 plus or minus the square root of 21, I'm going to do 5 plus or minus the square root of 21. My foci are going to be at -3, comma, 5 plus the square root of 21. I'm also going to have foci at -3, comma, 5 minus the square root of 21. Now these approximate values, very approximate values, are going to be about -3, comma, 9.6, and -3, comma, I think about 0.4. I'll label those in purple. So this is a horrible looking drawing. And those are your foci coordinates. Your major vertices, I said them already, I just never wrote them down. Your major vertices are going to be -3, 10, because it's along the major axis. The minor vertices, and -3, 0. And the minor vertices are going to be -3, 1. -1, 5. And this point, which was -5, 5. That's it, guys. See you in the next video.